Alright, this is where we left off in our last tutorial. We've made some progress, but we're still kind of working on solving this puzzle. Okay, so in this one we're going to do something really simple. In a previous tutorial, we looked through each box, and if you remember, we've been keeping that array of, so in this square right here, we have an array of how many possibilities show up in here. So like, we have an array that flags it as 1 can't go here because there's a 1 here, and 2 can't go here because there's a 2 over here. So we loop through all the squares in the boxes, and we said, is there any square, or is there any number that only shows up as possible in one box? One square in one of the boxes. And so we went through that, and I think we solved a couple new ones. What we're going to do now is, okay, so take a look at this square here. Now, what do we know about this empty square here? Well, we know that this row needs a 5, because there currently is no 5 in there. We also know that there's an empty square here, but a 5 can't go there. Okay, so no 5 there. We also know that there's an empty square here, but the 5 can't go there. And there's an empty square here, and the 5 can't go there because there's a 5 here. Okay? So in this row, the only square that a 5 can go is the square here. So there should be a 5 here. Currently, our puzzle isn't doing that. So what we're just going to do is we're going to loop through each row, and we're going to check if in the empty squares, if one of the if a possible flag shows up once. So here, we'd look at this and say, does the 5, can we put a 5 here? No. 5 here, yes. 5, no, no. Therefore, 5 goes here. So that's how we're going to be, that's what we're going to do in this tutorial. Okay, so I'm going to open up the puzzle.c and create a new file, and we will call this file row.c. Let's call that. And first thing we're going to want to do is include our Sudoku.h file. In every file we do that. Make the text a bit bigger. Okay, so we call it check rows, and again we're just gonna loop through each row to see if there are spots that can be solved. So check rows, and as always, I'm going to take a Sudoku, square, Sudoku, and we'll send it the boxes too. I'm not sure if we'll be using the boxes, but might as well send it. Okay, and upon failure, it returns 0. Okay, so we need some counter variables, so int I, j, k. And first thing we're going to do is we are going to loop through all rows. So that's a for loop for I is equal to 0, I is less than 9, I plus plus. Okay, so now what we're going to do is, another thing we need is we're going to keep an array of the sums. So remember I said we're going to go through and we're going to count how many times. So here, let's say a 3 can go here. I don't know if it can, but so if a 3 can go here and a 3 can go here, then for here we'll do 3 equals 1, here 3 equals 2. Therefore, since it's 2, we won't be able to solve for it. But for 5 can't go to here, 0, 1, 0, 0. Since it's 1, we can solve for it. So that's what this array is going to be. So one number for each number. If that makes sense. Okay, so we're going to loop through each square in the row. So that's for j equals 0, j is less than 9, j plus plus. Now, if the number is not 0, so if it's not an empty square, we just want to ignore it. So that's our first check. So if, and we'll do if Sudoku, which is our squares, at I, j is not equal to 0, then we're just going to continue. So I'll just go to the next iteration of the loop. And then we're going to loop through for each square. So when we're going to ignore this, then we're going to get to this square, and we're going to say, okay, can 1 go here? Can 2 go here? Can 3 go here? Etc. So we're looping through each possibility. So loop through all possibles. Sure. So for k equals 0, k is less than 9, k plus plus. Now we're going to check the possibilities. So if for the square that we're on, so this should be number. So if Sudoku ij possibles at k is equal to 0, then that means that it is possible. So true, it is possible. So then at some k, we're going to make an addition. Okay, so check if number is possible. It's k is possible. The other thing we need to do is at the start of our row loop, we need to initialize our sum variable to be all zeros, because this loop will run multiple times. So that's another for loop for j equals 0, j is less than 9, j plus plus. And we'll just do sum j is equal to 0. So that initializes sum. It's really a counter. Initialize. Laugh out loud. No. Initialize. Spelling, not my thing. Sum to 0. Okay, so that initialize, that counts that. And now, where are we here? So we've counted how many times 5 can go here, which is 0, how many times it goes here, which is 1, 0, 0, so it's equal to 1. So after we've looped through each square, so at the end of this for loop, we want to check, can we solve any? Which means we're again going to loop through sum. So this is another loop. So many for loops. Ideally, you'll only be running this section of the code once or twice, because you'd rather, there's just so many for loops that it just, yeah, you don't want to run this. That's why in our puzzle.c, it's puzzle.c, yeah. So it will be down here, like these two. Hopefully you never get to this section, right? You get to this section, and hopefully you return here, and then just keep looping through here, because the functions that are going to be down here will just take way too long. So anyways, tangent. Okay, so what are we doing? We're looping through the sum to see if any of the within this row if any of the numbers only show up once. Okay, so if sum at j is equal to 0, then we can solve it. Unless, so we need another statement in here. If it comes to this square, it's going to look at the sum and it's going to be 0. Sorry, 1. Should be 1, right? Yes, should be 1. So never mind, forget where I was going with that. Okay, so if sum is equal to 1, okay, so if sum is equal to 1, then we found a solvable square. So we now want to find out which square it was, because we've gone through all these, but we haven't kind of saved which one. So probably we could loop through them again, but maybe the best thing to do is to just add another another integer array. So let's do that. Let's just do call it place. Okay, so this is going to store where we found it. So here, some k plus plus. So this is at j. So place k is equal to j. So that's where we found it. Okay, so that's just saying, okay, so it's going to look here, skip that, skip that. If we're thinking of 5, then skip that because 5 can't go there, 5 can't go there, 5 can't go there, 5 can go here. So it's sum will get incremented. So 5 is going to be at 1. And then we're going to save, well, that's 3, 4, 5. We're going to save 5 in our place here. Okay? So j is equal to 5, so it gets saved here. Then we're going to go look at this, look at this. Those don't change anything. So the 5, sum at the 5 is solvable. So what we're going to do is it's 1, so it's solvable, and we have where it's solvable right here. So we can just go ahead and solve it. So if sum j is equal to 1, then we get to solve it. Yay! Okay, so this is I, and it's going to be, the position that it's going to be at, again, is place k. Okay, and that's going to equal j plus 1. Yeah, I hope that makes sense, because j is equivalent to, j gets incremented here. Wait, what are we doing here? Okay, that's kind of confusing. Maybe we should make this k. Let's change this to k. That'll make a bit more sense. So change that to k. Place k. Why is that place k? No, wait, that should be place k, right? Yeah. Okay. So place k is equal to k plus 1. Okay. So yeah. So place k goes up through the possibilities. So for here, it starts at 0 and it says is 1 possible. No. Then it goes up to 1, says is 2 possible, etc. So it gets to 4 and it says is 5 possible. Okay. Because remember, it's 0-based indexed. Okay, so at place 4, okay, so it's possible here, so it's saving this position. J gets saved in here at your place K, and then we can just call that column out. So this is really your column place. and it just got saved there. So that, yeah. Anyways, okay. Ask questions in the comments if you have any more questions about that. That kind of maybe needs its own video. Not that it's the most complicated thing that we've done. Okay, so we're solving it. So this is the number. So number. Oh wait, another thing is we need to always, this has to also get initialized to 0. So place j equals 0. Okay, initialize sum and place. So we save the column, we store the number, which is k plus 1. Then what do we do? So this is, remember, we also have that solvable variable from a previous tutorial. So that needs to get set to 0. And that global variable unsolved, which keeps track of how many squares are left, that needs to get decremented. And then what we need to do is we need to call our update Sudoku function from a previous tutorial. And that's just going to be Sudoku I and k. Nope. Place k. I and place k. So that tells us where, that tells the update Sudoku where it got solved. Then we'll just copy this, and we also have that update boxes. So we'll call that as well. Okay, and then we'll return 1 because we want to stop right here. We don't want to keep going through. If we solve 1, chances are some of these will work. So we don't want to keep running down here. Okay, so we will add this in. So we don't want to return. We do return box singles, that will always fail. So we'll say if box singles. So this is saying if it's true, which means if it's 1, then return 1. And then here it's going to be the same thing. No, this is a little n, so we can just do return check rows. And pass it Sudoku and boxes. Okay, so that's a fair bit. It's going to be interesting to see if it actually worked. Okay, so we're going to clear this, we're going to make it, and it did not work. Interesting. Very interesting. So let's see, we are calling it return check rows. Okay, so what went wrong? Now we get to debug. What fun. Again, we're looking for this 5 to get solved here. So okay, so the problem was it was on my end completely. So I had to refresh something. So okay, so trying it again, we actually get a error here. Square has no member named possibles. So that's a slight problem. And so in our row.c, possibles, just get rid of that. Try it again. And would you look at that? Sorry, I added an error message there. Okay, so yeah, look at that. It solved it, I believe. I actually had another program that I was using to help solve it. A little more advanced than what we've been using, but we can use this to kind of verify that it's the correct solution. So I mean, it looks right, and I've checked it before and it was right then, so I think that means that we have solved this puzzle. Woo-hoo. Yeah, so that's pretty exciting. Obviously, this isn't the most difficult puzzle, but we have a pretty robust program at this point. And maybe in the next tutorial, I'll kind of play around and see exactly what it's capable of solving, and maybe we will even start timing it and things like that. But yeah, so that's pretty cool. I would say that this has been a success. You can now solve all your Sudoku puzzles.